Hi everyone, this is another computer video in the computer video series, and this one is about compilers. In this video, I'm going to talk about what a compiler is, the different types of compilers, and the process a compiler goes through in order to deliver its output. So let's get started. So first we have to start off with the basic question, what is a compiler? If the software on a computer is written in one kind of computer language and needs to be converted into another computer language, a compiler comes into play. A compiler is a program on the computer that, like I just said, takes one computer code, analyzes it and understands it, then converts it into another code. This converting of codes is necessary in order for the computer to understand the code and thus complete the task. Think of a compiler as a translator from the user to the computer. The compiler understands what the user is saying and translates the task or instruction to the computer by converting the programming code typed by the user into a computer code. The action of the compiler understanding the programming language and making meaning of the programming language is called semantics. Well, what does a compiler do? So when a user needs some software to be created, the user creates something called a source code. A source code is the programming language that the user codes and that is readable to humans. This source code is then analyzed by the compiler and turned into a computer code, which is one part of the compiler's job, converting the source code to a computer code. When the compiler first converts the source code into a computer code, however, the programming language that is being used is a complex one, and in order for the computer to be able to carry out the plan the user instructed, the compiler must turn this complex computer code into a simpler computer code. The compiler thus keeps converting a code into another type of lower level or simple computer code, until it gets to one that is easy for the computer to work with and deliver a task with. The difficulty of the computer languages goes from languages such as Pascal and C language, which are high-level languages, to assembly language, then to machine code, which is the kind of language the compiler tries to get the computer language to. Finally, this language is ready for the hardware, as shown by the picture. So to sum it up, when the compiler first converts the source code to the computer code, it starts off with a high-level language and converts it into a lower-level language until it gets to the machine language, which can then be processed by the computer and given to the hardware to implement. Types of compilers. So there are many different kinds of compilers that each have their unique functions within trying to convert languages and understand programming languages. One is a cross-compiler. A cross-compiler is able to create code for more than one operating system. For instance, if the compiler is a program on Windows but is creating a code for Linux, then the compiler is a cross-compiler because it is working across different operating systems, Windows and Linux. Contrasting to this kind of compiler is the native code compiler, which is more of a general compiler and only works on one operating system. So remember how I talked about how compilers convert high-level or complex code, such as Pascal, into low-level code, such as machine code, in order to let the computer understand the task and thus perform it? Well, there is a kind of compiler that converts high-level code into another kind of high-level code, or low-level code into another low-level code. Now you may ask, what is the purpose of this? Well, this source-to-source compiler leaves the final code looking similar to the source code, which makes the code less likely to get errors while the compiler converts it, although it may be harder and it may take longer for the computer to deliver the task. Another kind of compiler is a source compiler. This is different from a source-to-source compiler as I just talked about. A source compiler is only able to turn a high-level programming language into a specific kind of low-level language, called an assembly language, as I talked about earlier. This makes it harder for the computer to implement the task because the assembly language is not a machine code, but it is still rather efficient because an assembly language is a lower-level language. There's also a compiler called a threaded code compiler. This compiler simply takes code made up of letters and converts it into a code made up of ones and zeros, called the binary code, which is a machine code and thus easy for the computer to work with. Finally, there is the one-pass compiler. This, like the name suggests, goes through the whole process of converting different leveled programs into other codes in one step. So it goes from a high-level language to a machine language in one step. Now there's also a term called the compiler. This is not a type of compiler, but is a term that refers to a machine that is like spell check for a programming language, and it looks for improper forms of codes, or if there is a mistake or typo which was made in the programming code or source code. This allows for more efficiency because if there is a mistake in the code, the compiler will not fix it and will take whatever the typo in the code is literally. For instance, if the code said print, but the user meant print, the compiler will use print and will make an error in the final code. But the compiler would prevent this from happening. The action of the compiler reading the code literally is called syntax. So the job of a compiler is syntax analysis. So the compiler, as you can see, would take the print, and then the compiler would come into action and would change it into print, and then the general compiler would complete the task and use print, and there would be no error. And syntax analysis would come into play with compiler. The compiler's process. So far I've talked about the different kinds of compilers and what functions each type has. Well, again, a compiler in general always comes down to creating a code using the source code that is usable for the computer. Well, there is a certain process the compiler goes through to make this happen. First is pre-processing. Pre-processing is when a computer program analyzes the data that is inputted, the source code, and turns it into sentences, and this analysis is then used by the compiler to carry out functions. Then comes lexical analysis. This is the actual first step the compiler takes in the process of understanding the source code. Lexical analysis is when the compiler takes the analysis done by the preprocessor and converts the syntax of the sentences into tokens. Tokens are groups of characters that are in a programming language which help to simplify the code of the sentences, as shown by the figure. Next is syntax analysis, usually done by the compiler as discussed before, where the compiler fixes the characters in the tokens of the programming language if there is a typo or error. Semantic action then takes place where, like I said before, the compiler comprehends the revised code provided by the compiler. Next, the compiler converts the programming language of the semantic analysis and converts it into a virtual machine language called an intermediate representation, which is a lower-level language code or an assembly language, and basically represents the source code interpreted by the semantic analysis, and the compiler uses this code to further carry out the task given. Then the compiler takes the code from the intermediate representation and turns it into a form that can be easily and efficiently used by the computer to execute the task, such as a machine code. Now, the intermediate representation was for the compiler to understand what was going on in the code and for the compiler to analyze it. But now, the compiler has turned it into this machine code, which the computer will now be able to understand and complete the task. The process of converting the intermediate representation into the machine code is called code generation. Finally, the compiler has an operation called code optimization, which makes the software and code run more efficiently and smoothly, and this helps the computer carry out the task with the code given by the computer. So that's it for compilers in this video, and I know it might have been really technical, especially the last slide. And if you have any questions, please be sure to leave them in the comments below, or if you have any additions to this, or if you have any ideas for future videos, then please also include those in the comments below. And here are just a couple of citations I used for this video, such as the content and the pictures. So here are just a couple more citations I used for this video, just picture citations. So here are a couple more citations for this video. And finally, here are the last bit of citations for this video. I hope you learned a lot from this video, and again, leave comments or questions or ideas. And be sure to subscribe if you like these kinds of computer videos, and I'll be sure to be making more computer videos. And feel free to check out other computer videos because it'll definitely help you learn not only computers, but it'll help you understand more about this video in particular. And yeah, I think that's it for this week, and I'll see you later. Bye.